Bismillahirrahmanirrahim. Dear students, we are continuation with the chapter number 4 for the gases, and this is lecture number 34 and the chapter number 4 grade 11. So the topic is relationship between temperature and average kinetic energy of the particle of the gases. Topic relationship between temperature and average kinetic energy of particles of gas. This is the 4.21 particle. Now, as we done the kinetic molecular theory of gases, these points, the kinetic energy of the gas molecules depend upon temperature. If we increase the temperature, the kinetic energy of gas molecules also increases. So, average kinetic energy of gas molecules depend upon absolute temperature. So, derivation of relation between the kinetic and the temperature. So, in the last lecture I told you kinetic energy equation and kinetic equation. So, there are two equations. This is the kinetic equation. PV 1/3 mn c square bar. This is called the kinetic equation. And there is another equation that is called kinetic energy equation. So kinetic energy is equal to half mc square bar. So there are two equations, dear students, we have. One is called the kinetic equation, P pressure, V volume 1/3 and mass of the 1 mole of gas, number of moles and square mean velocity. Kinetic energy also equal to half m mass of the gas and c square bar. So if you are going to multiply and divide by this one, then you have this equation. If you use this equation, multiplication divided by 2, then you have equation nu PV is equal to 2/3 number of mole m, 2/3 number of mole m, half m c square bar. You will get like this equation. So this is a half mc square bar is equal to kinetic energy. So that is why PV is equal to 2/3 m kinetic. This is equation number 4. Now n the number of moles, n are the number of moles, and 1 mole of every gas is equal to Avogadro's number. So Avogadro's number is divided by this one. So it means this equation can be written in this form. like this. This equation can be written in PV is equal to 2 over 3 Avogadro's number and kinetic energy. Now students, there is a very important equation we call general gas equation. That is P V is equal and R T. This is called a general gas equation. So, where n is a 1 mole of gas, we have to omit this. Then PV is equal to PV. Instead of PV, I write 2 over 3 and a kinetic energy is equal to R T, where the N is a 1 mole of the gas. N is a 1 mole of the gas. So now if you are going to rearrange this equation, then 2 like this, in this form. And if you are going to write, take out the constants. Take out the constants. So, kinetic energy will be is equal to 3 constant. R is a universal gas constant. 2 is a constant. Number of moles are constant. T. This is equation number 7. Now these are constant K. Like this. Now if you rearrange this one, then kinetic energy is equal to K T. Means kinetic energy is directly proportional to the temperature. So average kinetic energy of gas molecule is directly proportional to temperature. So this is the relationship. Kelvin temperature of gas is actually a measure of average translational kinetic energy of its molecules. In gas and liquids, the temperature explains the average translational energy of the molecules. In solids where molecules cannot move freely, so temperature becomes measure of the vibrational kinetic energy. This is the conclusion for this topic. Derivation of relationship between kinetic energy and temperature. So we concluded that Kelvin temperature of the gas is actually the measure of average translational kinetic energy of the molecule. So it is kinetic energy is directly proportional to the absolute temperature. So here is the conversion. You can convert very easily this one. What is the kinetic total energy of translation in Earth of 2 moles of perfect gas at 27 degree Celsius in Kelvin. So number of moles are 2, temperature is 27 plus 273, you will have 300 Kelvin. So if you are going to do this one, now students, if you do this, kinetic energy is equal 3/2 nRT. So kinetic energy is equal 3/2 and number of moles are 2. R is a gas constant, so in the unit Earth, that's 8.314 into 10 to the power 7 Earth per mole per Kelvin. Actually, we have to write the units, so then I will tell you this. There are units and values for the R Rayleigh gas equation. So we have to do this in the class. 1 joule is equal to 10 to the power 7 Earth. So we will have to derive this one. So this is the unit value of R. So instead of R, I have to put 8.34 into 10 to the power 7 Earth per mole per Kelvin, multiplied by temperature is 300 Kelvin. So if you solve, then kinetic energy will be is equal to 74 83.5 into 10 to the power 7 Earth decimeter cube. So this is the value of kinetic energy by using this formula. Number of moles given, value of R is a constant in Earth's, temperature is given, so you have to put these values in the equation and calculate this one. Now, in the starting of this chapter, I told you gas molecules have large empty spaces between the gas molecules. So that's why it exerts pressure, and in our daily life there are many applications for this. For this, gas can exert pressure. So dear students, pressure in the light of kinetic molecular theory of gases. Already we done in the kinetic molecular theory of gases that gas molecules move in a straight line. The direction is only changed when they collide with themselves or with the wall of container. And average kinetic energy of gas molecule is directly proportional to Kelvin temperature. So average kinetic energy of collision when the gas molecules collide with wall of container will not change at a constant temperature. If you make the temperature constant, So there will be a no change, means at the same temperature there will be a random motion of the gas molecules, but if you change the temperature, then average kinetic energy of the gas molecule is going to change. So here are different units of pressure. Gaseous pressure and its various units. Gas, when you are going to apply pressure and different units. So, dear students, force per unit area is called pressure. Pressure is equal to force per unit area. Force per unit area is called pressure. So pressure is measured in Newton as a force, joules, force in joules, and area in meter square. So that's why pressure is measured in Newton, force Newton, force is equal to joules, and area per meter square. That's why the pressure is equal to joules per meter square. Nice one. It is a joules per meter square. There is another unit of pressure we call Pascal. A force of 1 Newton Pascal, a force of 1 Newton spread over an area of 1 meter square is called Pascal. The force of 1 Newton N or Newton spread over an area of 1 meter square is called Pascal. So there are many units we have defined. This is only one or two. Joules per meter square, and there is another very important unit, Pascal. The force of 1 Newton spread over an area of 1 meter square is called Pascal. So there are the units. You heard about that. There are many units. So SI unit of pressure. System International Units. System International Unit of Pressure is Pascal. Same definition I told you. Unit of force in newtons and unit area is a meter per square. So newtons per meter square. Pascal is a SI unit of the pressure. So newtons per meter square. Newtons per meter square. So generally we calculate the pressure in atmosphere. 1 atmosphere pressure. One atmospheric pressure at a sea level when you maintain 0 degrees Celsius. 0 degrees Celsius at a sea level, the standard pressure is a 1 atmospheric pressure. By using the manometer, barometer as the instruments used to calculate the pressure. Manometer is a modern device to measure the accurate pressure. So mercury is used. So this is also called 760 millimeters of mercury. Also it is called 760 torr. Also it is called 101,325 Pascal, or is equal to 101.325 kilopascal. So there are many units you can mention here, and also there are many units. 1 calorie is equal to 4.18 joules. So dear students, these units we can use in our daily life when we are working with the gases, because gases exert pressure. Liquids very low. Solids do not. The reason I told you already that there are large spaces present between the gas molecules. That's why gases exert pressure. So we are working with the different gases at different times and different experiments and uses also. Okay. Now these are the interconversions. 10 pascals into kilopascals. I told you 1 kilopascal is in a kilopascal. 101.325. So first of all you have to change the 10 pascals. This is a pascal. 101.100.101.325 pascal. And if there are 10, so then you have to divide this one. 10 divided by 1000, you will get a kilopascal, then multiply by 10. So there are also other atmospheric pressure you can change into millimeter of mercury. Millimeter of mercury can be changed into atmospheric pressure. Now, we done in grade 9. These topics you done in the grade. These are the units we use in different calculations. Now, students, gas laws. Gas laws. So number 1 is called a Boyle's law. In grade 9 you done this also. the volume of given mass of gas is inversely proportional to the pressure where the temperature remains constant. So volume of given mass of gas is inversely proportional to the pressure where the temperature is remain constant. This temperature is a constant. Then if you increase the pressure, the volume of gas will be decreased at the same rate. This shows the inversely proportional. So V is equal to 1 over B means minus 1, or PV is equal to constant. PV is equal to constant if you are going to change. This is an initial pressure, this is an initial volume. After changing the pressure, this will be a P2 and V2. This is the Boyle's law. Pressure 1 initial, volume 1 initial. After changing the pressure, the volume is going to be also changed according to law. Means if you increase the pressure, the volume of gas also it is going to be decreased, inversely proportional with the so this is the Boyle's law. Then one thing, if you are going to plot a graph, if you want to plot a graph of Boyle's law, pressure and volume, or 1 over density. So if you are going to plot pressure versus volume, means directly, this is against the law. Here V1 over P means, but here you are plotting the graph against the pressure and volume. So at a constant temperature, suppose you maintain the temperature 25 degrees Celsius, so you will get isotherm. This is a T1 temperature. This isotherm is at T1. Iso means same, therm means heat. So at the 25 degrees centigrade, you will get a curve we call isotherm when you plot a graph against pressure and volume or 1 over D. But if you increase the temperature, suppose this is now 50 degrees Celsius and this is a T2. So when you increase the temperature, the curve, this isotherm will go away from the volume. You will get another isotherm curve. Increase more, you will get like this one. So when pressure of gas is plotted against the volume at different temperatures, so we will get a family curve, hyperbola, with a difference value of k, each curve known as isotherm, constant temperature plot. As the temperature is going to be increased, the curve isotherm go away from the both axes. This is because higher the temperature, the volume of gas is going to be increased according to Charles' law. As the temperature increased from 25 to 50, this position of the isotherm is going to be a change, it will go away, because by increasing temperature, the volume of gas is going to be increased. But dear students, if you are going to plot, if you want to plot a graph of pressure 1 over V, means if you put the density or 1 over V, this is according to Boyle's law. Inversely, this shows the inverse relationship between pressure and volume. Then you will find straight line passes through the origin. You will find a straight line passes through the origin. And you are plotting, suppose this is the 25 degrees centigrade and this is the T1. And when you are going to plot a graph at higher temperature, so 50 degrees Celsius suppose, this line will away from 1 over V and it will move towards the pressure, near the pressure. And if the third change in temperature, so again you will get like this one. It means that temperature T1 is less than T2 and less than T3. So T1 is less than T2, less than T3. So this is according to Boyle's law, which shows volume of given mass of gas is inversely proportional to the pressure, where the temperature remains constant. Very simple numericals are given here. Suppose you have a volume V1 about 0.300 decimeter cube and pressure in Pascal 1.80 into 10 raised to the power 5 Pascal. This is the P1. What volume V2 when the P2 is going to be changed 1.15 into 10 raised to the power 5 Pascal. So dear students, you can see the result when the volume of gas is 0.3 and this is the pressure 1.8 10 raised to 5 and this is the 1.15. So when the pressure is decreased, the volume is going to be increased. So when you apply this equation, V2 will be equal to P1 V P1 V1 over P2. So if you are going to put the value of P1 1.80 then this part 5 divided by P2 1.15 into 10 raised to the power 5 multiplied by V1.30 decimeter cube, then you will get the answer. I told you the volume of the gas is going to be increased because you are reducing will be a 0.469 increase, decrease pressure. Pressure is decreased, the volume of gas must increase. So you have to solve other numericals like this by using this formula. Again, activity of the students. Volume is given V1, pressure is given P1. Same question, what volume V2? When the pressure is reduced from 770 to 750, means the volume of the gas will increase. As you see the answer in your book, 375 volume, now it becomes 385. So as you decrease the pressure, the volume of the gas is going to be increased. So this is called Boyle's law. Now, Charles' law. According to Charles' law, the volume of given mass of gas is directly proportional to the temperature where the pressure remains constant. It means that when you increase the temperature of the gas at a constant pressure, the volume of gas is going to be increased. So that is why V is equal to Kp. So V over P is equal to K. So this is the V1 initial volume, T1 initial temperature, so V2 final volume, and T2 is a final temperature. Both sides must be equal in the both cases. In the Boyle's law and the Charles' law, these left side should be equal to the right side. So Charles' law, I told you, this was 1787. At a constant pressure, the volume of gas, mass of gas increases or decreases as we done the critical definition of Charles' law. 1 over 273 times its original volume of 0 degree centigrade. For every 1 degree centigrade rise or fall in temperature respectively is called Charles' law. For this preliminary investigations, Charles' law observed that gases such hydrogen, very lightest gas, carbon dioxide gas, heavier 44 molar mass, oxygen little bit heavier 32 molar mass, etc. expanded equally. They will expand equally on heating from 0 to 80 degree Celsius at a constant temperature. So students, this is the Charles' law, and we explained the two laws, Boyle's law and Charles' law, and pressure also. So we are going to stop here, and I will continue this topic with the derivation of critical form of the law. Next topic will be the derivation of critical form of the law. So we finish it. Thank you very much.